In this video, you will, as the lesson title indicates, explore different angle relationships, including angles that come in pairs. Some of these are a review from 8th grade geometry, and some of them are brand new. You will also learn how to use a protractor to measure an angle. Take a look at the first problem on the back of the first page of your notes, entitled How to Use a Protractor. In this example, you will learn how to use a protractor to measure an angle. The protractor looks like this. Make sure you're right side up and not upside down. And this is called the point of the protractor. Most all protractors have two scales, an inner scale and an outer scale. To determine which one to use, you need to take a look at the angle that you're given and look at the initial or first ray. That's this one right here. It just happens to be one of the two rays that's most convenient to use. Since this is moving to the right, then we're going to use the scale starting at 0 on the right side of the protractor. Always start at 0 regardless of which side of the protractor you start on. To measure the angle, you put the point of the protractor, which is right in the center, on the vertex of your angle, point K, vertex K, and then line up with the markings on the protractor at 0 degrees. Do it accurately and carefully. If you need extra ray, you can always extend the two rays. Then you have to make sure you start at 0. If we use the outer scale, we're starting at 180 and then moving back to 170, 160, and so forth. But we want to start at 0, as I indicated. So start at 0 and start moving around until you get over to the other ray. We have 10, 20, 30 degrees, 40, 50, 60, 70, 80, 90, 100, 110, 120, and then after we get to 120 degrees, we move over a little bit. 1, 2, 3. So that's 123 degrees. The problem asked us to use a protractor, but to also make a geometric statement about the measure of the angle. So the measure of angle JKM equals 123 degrees. Now we could have written this in two other different ways, and we'll go over that here in this next example. Example 1. In this example, you will see there are different ways to name the same angle in geometry. Part A. What are two other names for angle 1, this angle right here? And B, name the largest angle in the diagram. Before we talk about measuring this particular angle, we need to talk about why would we want to use 3 letters to name an angle. If I have an angle, let's say angle ABC, I really don't need to call this angle using 3 letters. I could just say this was angle B. So why do we have to use 3 letters sometimes? That's because sometimes angles have other angles associated with them, and the vertex of that angle is being used in other angles. For instance, this one right here, angle ABC, if we were to call this angle B, it wouldn't communicate exactly what we needed, because angle B could either be angle ABC, or it could be angle CBD, or it could be angle ABD. So this is the reason why we use 3 letters. If they give you an angle with only 2 rays like this, you can go ahead and call it angle B. But for this angle here, angle 1, has another angle associated with the vertex at M. So when we name this angle right here, they wanted 2 other names for angle 1. We can name it angle JMK, and we can name it angle, and just go the other way around, KMJ. Now, one other thing is very important to remember. the vertex must be between the other two points in the angle. If we were to want to name this angle JMK and we named it angle JKM, K would be in the middle, and that would be some sort of angle that goes like this. So it's very important that you make sure that the middle letter in naming an angle with 3 letters is the vertex. Part B, name the largest angle in the diagram. That would be, it wouldn't be angle JMK and it wouldn't be angle KML. It would be both of them put together. Angle JML. Or you could call that angle LMJ. Example 2. In this example, you will learn more how to measure angles with a protractor and review classifying angles by their sizes. What are the measures of angle LKN, angle JKL, and angle JKN? Classify each angle as acute, obtuse, right, or straight. Now, in this example, we do not have to actually use a compass for ourselves. They superimpose the compass, a protractor, over the drawing itself. So all we have to do is use this one. And you can measure angles with a protractor without starting at 0. It's a little bit more complex, but you can do that. And in example 2, they wanted us to find the measure of angle LKN. First of all, so locate the middle letters K, of course that would be the vertex, and then ray KL right here, and ray KN right over here, means that we're looking at this angle right here. Well, in this case we are starting at either the right side of the protractor or the left, in this case the right, so we can start at 0. Start at 0 on the inner scale on this one. Start at 0, go around until you get over to ray KL. So this is 10 degrees, 20 degrees, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and it looks like it's at 145 degrees. So the measure of angle LKN is 145 degrees. Then we classify that angle by its size. This angle here is greater than 90 degrees, so therefore it's called an obtuse angle. The second one they asked for was for us to find the measure of angle JKL. So search or look for point J, which is right here, ray KJ, and the other side of the angle is ray KL, so from here to here. So we're looking at this angle right here. Now, since neither one of these rays start at 0, we're going to have to either start with this ray or start on that ray. I'm just going to start at this ray right here. Each one of these scales, it goes by 5 degrees. So we have, if you'll notice, it's from 30 to 40 from here to here, so this would be 5 degrees here. So we have 5 degrees, 10 degrees, 15, 20, 25, 30, 35, 40, 45, 50, 55 degrees. So the measure of angle JKL is 55 degrees. And since this angle measures less than 90 degrees, this is an acute angle. And finally, the measure of angle JKN, repeat the process. Look for J, ray KJ, and ray KN. This time KN is at 0 again. So from 0, we move upward all the way up to ray KJ. 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. And because it's exactly 90 degrees, we have ourselves a right angle. Example 3. In this example, you will learn how to identify angle pairs given a geometric diagram Use those angle pair definitions to make geometric statements and then draw conclusions based on those definitions. What can you conclude from the information in the diagram below using the definitions of different pairs of angles covered in this lesson? So let's take a look at the diagram. You've got two lines that intersect, and you've got one ray coming out from this intersection point. We've got two arcs drawn on angles 1 and 2, which indicate that they're congruent. Let's start there. Angle 1 is congruent to angle 2, and we're going to make some sort of reason, or come up with a reason why that is. It's by the definition of congruent angles, or it's because of the definition of congruent angles. So by definition of congruent angles, because the definition of congruent angles states that if two angles' measures are the same, then those two angles must be congruent. It's that simple. Looking around our diagram, one thing we notice is that angles 3 and 5 are vertical angles because these two lines intersect and these are opposite each other. They're vertical angles. So angle 3 and angle 5 are vertical angles. And then we're taking a look around again. The linear pair of angles, if you'll notice, we have a linear pair of angles here, angles 3 and 4, and we know this because added together they create a line. So angle 3 and angle 4 are a linear pair of angles. Take a look at angles 4 and 5. Angles 4 and 5 also create a line, these two. So angles 4 and 5 are also a linear pair. Are a linear pair. Take a look at, are there any other linear pairs? No, there's not. There has to be two for a pair. Those are the only combinations. We have a whole bunch of adjacent angles. So the following are all adjacent angles. Adjacent means next to. And remember the formal definition, adjacent angles have to share a common ray and they cannot overlap. So for instance, let's take a look back at angles 3 and 4 again. That was a linear pair, but they're also adjacent angles because angle 3 and angle 4 share this ray and they don't overlap each other. Angles 3 and 4 don't. So angle 3 and angle 4 are adjacent. Take a look at angle 3 and angle 2. Angle 3 and angle 2 are adjacent. What about angles 2 and 1? Angles 2 and 1 are adjacent. Another pair of adjacent angles would be angles 1 and 5. And then coming over below, we have angles 5 and 4 are adjacent. And then we're back over to angles 4 and 3. So there's 1, 2, 3, 4, 5 pairs of adjacent angles. Then we have supplementary and complementary angles. Well, we don't have any complementary angles here that we know of because, first of all, there are no measures provided. Also, we don't see any right angles formed anywhere. But for supplementary angles, we do. Remember, any linear pair of angles are also supplementary. So angles 3 and 4 are supplementary angles. See if you can find another pair of supplementary angles. Angles 4 and 5 are supplementary. Remember, they're supplementary because their sums add to 180 degrees. Now, you can have more than 2 angles being supplementary. So what about angles 1, 2, and 3? Those are supplementary also. Angle 1, angle 2, and angle 3 are supplementary angles. What about angles 5, 1, and 2? Angle 5, angle 1, and angle 2 are supplementary angles. Right there. They all form a line altogether. Example 4, using the diagram at the right, is each statement true or false? Explain each. So we have parts A, B, and C. We've got a diagram with quite a few rays and angle measures given. Part A, angle BFD and angle CFD are adjacent angles. So trace those out. Angle BFD, it's this one right here, and angle CFD, that's this one right here. Now, they seem to have something to do with each other. Are they adjacent? No. False. Aren't they adjacent? Well, they don't share. They share a ray together, but they're not adjacent. They overlap. So the reason why this is false is because, let's write not adjacent since angles overlap. Angle BFD overlaps with angle CFD. This part right here is being overlapped. Okay. Part B. Angle AFB and angle EFD are vertical angles. So locate angle AFB. It's this one right here. And angle EFD is this one right here. At first glance, you may think they're vertical, but they're not vertical angles. False. Why? Because vertical angles are created by 2 lines that intersect, creating opposite rays on their non-common sides. So, even though this is a line, this right here is not a line. It suddenly moves off this direction. So this angle right here, angle EFD, is not vertical angles with angle AFB. If this ray had continued to go this way, then we would have a pair of vertical angles. So we can write something like this. Ray FB and ray FE, FB and FE, are not opposite rays. This is not an opposite ray with this one. C. Angle AFE and angle BFC are complementary angles. In other words, they're complements of each other. So angle AFE, that's a 62 degree angle here, and angle BFC, that's this 28 degree angle here. Well, just by looking, you can't tell that they're complementary. Remember, complementary angles are angles that add together and give you a sum of 90 degrees. But if we test it by adding the measures of these 2 angles up, let's see if we happen to get 90 degrees. 28 degrees plus 62 degrees. When we add them together, we do get 90 degrees. So this is true. And explain, we can say something like this. The sum of the 2 angles is 90 degrees. And there's our proof right here. Example 5. In this example, you will learn how to draw and label a geometric figure and then find the actual measure of an angle when an angle bisector is involved in the process. Draw and label the following geometric situation. Ray QR bisects angle PQS. And then they ask us to solve for x and find the measure of angle PQS if the measure of angle PQS is 4x minus 6 degrees and the measure of angle PQR is x plus 11 degrees. So first things first, let's draw this. Take a straight edge, whether it's a ruler or the back end of your protractor. We need a ray QR that bisects angle PQS. So let's start off with the angle. And it really doesn't matter how big or small you make the angle. Just make it big enough to have some interior for it. There's our common vertex, common endpoint for our vertex of the angle. Q must go in the middle or in between. Since it's in between in the naming, it has to be the vertex, Q. P can either be up here or over here. I'm going to put P up here and S over here. So we now have angle PQS. Ray QR bisects that angle. So find about where, you don't have to use a protractor to measure it out perfectly. We just want something that looks like it's bisecting the angle. Remember, an angle bisector is a ray that goes through an angle or cuts through it, divides it into two equal parts. So we're going to just say that these are equal in measure. We use little arcs to show that. Don't forget to put your point R over here. So here's ray QR, which is an angle bisector. Now that we have that ready, we can go ahead and do the second part of the problem. They want us to find the measure of angle PQS, this whole thing, if the measure of angle PQS, this whole thing, is 4x minus 6 degrees, and the measure of angle PQR, which is PQR, this one right in here, is x plus 11 degrees. Well, because an angle bisector divides an angle into two congruent parts, that means that whatever the measure of this one is, if we double it, we'll get the measure of what we're looking for, the measure of angle PQS. So before we do that, let's go ahead and make a statement. By the definition of angle bisector, the measure of angle RQS is equal to the measure of angle, that's RQS, is equal to, it's right here, the measure of angle PQR. The bisector cuts this angle into two angles that have the same measure, so RQS is equal to PQR. Then, or so, the measure of angle PQS, the whole thing, we said, can be found by doubling just one of them. So let's set that equal to 2 times the measure of angle PQR. Now we substitute in the algebraic values for those. PQS was 4x minus 6, so 4x minus 6 degrees equals 2 times the measure of angle PQR was x plus 11 degrees. Using algebra, we use the distributive property. We get 4x minus 6 equals 2 times x is 2x plus 2 times 11 is 22. To solve this equation, to get rid of one of the variables on one side of the equation, we subtract 2x from both sides. And we get 2x minus 6 equals, those go away or become 0, equal 22. Solving for x, we need to add 6 to both sides. We get 2x equals 28. Divide both sides by 2, and x is 14. Now, it didn't ask us for the value of x, even though we needed to find it. But now they asked us to find the value of the measure of angle PQS. So remember, that was twice the measure of angle PQR. So that's 2 times the measure of angle PQR in our problem was x plus 11. So x was 14. We substitute that in. We get 2 times 14 plus 11. 14 plus 11. So we'd have 2 times 25. And that gives us 50 degrees for the measure of angle PQS.